the biggest question that I keep getting asked is observability. Why should we bother about this at all? Like it exists everywhere. And you've seen this photo a lot of times on CNCF. Now this keeps coming up. This keeps on growing, like keeps on growing. There's always a new project. There's a new vendor who'll come out, tell you that, hey, we are the best observability product out there. No offense to people who spoke before me. I thought I was the first guy to speak today. But yeah, so if I offend anybody, that's accidental. But they keep coming up. Now the question that we ask is, how do we make sense of this? At an organization, do I need this on day one? Do I need this on day 100? What do I need on day one? What do I need on day 100? That's a common question. Like all of you are SRE and DevOps. You may have this plight as well. You have to go convince your executives that, hey, I need this tool, but I already have one. I already have logging. Why do I need anomaly detection? Why do I need another graphing tool? Why do I need another charting tool? After this talk, you'll find it easy to explain it to them. Yeah. Key takeaways. I want a mental map of observability maturity, something that you already have, but you can carry home as well. How to think in terms of outcome before getting deluged by the features of all these tool chains that throw at you. The next time there's a new tool chain, there should be a mental model of, okay, this is exactly where it sits. This is the problem that it solves for me. Now, why am I eligible for this? I don't know. He invited me for the conference, but a bit about, these are like show off slides. So, I've built a time series data warehouse at billion cardinality. My cardinality is bigger than his cardinality. So, and observability SaaS that powers the likes of Disney, Hotstar, and I built DataStax Cassandra SaaS in my earlier life. So, not as the scale of Google, but have some experience dealing with this. I love Occam's razors, like a simplest explanation that should, a good principle to explain phenomenon by the simplest hypothesis available. I want to take observability and try to explain it in the absolute simplest, dumbest terms possible. Now, you may be smart, I'm dumb, so I use it for me. Let's see if it works for you as well. The most debuggable system is the least debugged system. Sounds like paradoxical, right? Now, cool, let's dive right into this. I'll take a very simple, dumb example. We've seen this. Internet's not working. What could be wrong? It could be the computer. It could be my Wi-Fi device. It could be an internet modem. It could be the ISP. Could be anything. Like we run into this. How do we generally debug such problems? The first thing is we see, is my device working or not? Step one. Step two, is the Wi-Fi working? Step three, is the modem working? Or if all of them are working, then it must be the ISP. There's something happening in here. We have a mental algorithm of how we are going about debugging this problem here. It's a very simple problem. Internet's not working. And I'm going step by step to identify where could the problem lie. Step one, do both laptop and mobile have the same problem? I look at my laptop, I look at my mobile. Yeah, both of them have the same problem. I go further. I see, can the devices connect to the Wi-Fi? Yes, they can. Go further. Is the Wi-Fi light blinking green? Yes, it's blinking green. I go to the modem. Is the modem light blinking green? Yes, it is. Certainly the problem lies with the ISP. Now, this is a sequential step that we have taken. Let's look at it. What are we doing here? We are saying a single system can be divided into subsystems. We had internet as a problem, but I'm able to divide this into multiple smaller steps. And I'm looking at each system and saying that must adhere to a promise. Until a promise is not met, I'll keep repeating, start from the step one again. Now, this is a general algorithm that I'll follow to debug any problem. This is what you guys do as SREs as well, as DevOps as well, anytime there's something going wrong in production. This method is called fault tracing. Complex systems should be broken down into smaller subsystems. Inspecting each subsystem makes it easier to find the subsystem that is not adhering to its promise. All right, a lot of words. I'll make it simpler. Let's break it down. What are the subsystems here? Device. What is the promise that it must have? Both the laptop and the smartphone should be able to connect. If they don't connect, there's a problem. The router. What is the promise that it says? If the light is green, everything is good. I don't need to inspect it any further. What does the modem say? If the link light keeps on blinking green, I am good. You don't have to look any further beyond me. Look at the other side. Hence, the best debug device is the one that you do not debug any further. They have taken care of all that data underneath and they are representing it as a single light. All the data, anything that could go wrong is down there, is underneath, and they aggregate it to say, here's a light. If this light goes red, look inside me. Otherwise, do not bother, look elsewhere. That's the Occam's razor of observability. The best debugged systems are the ones that you debug the least. So if you want to spend less time debugging a system to find out what's going wrong, make sure that system has everything about it which is observable so that you don't have to look at it. The paradox. No, it's important because this is exactly what observability is built around. What is observability? Is a tangible ability to draw inference of a state of a very complex system without interrupting the system. Just by looking at it, you should be able to say good or bad. Good, great. Bad, go within. Keep going within until you find that smallest subsystem, which is the problem. What's the secret sauce? Keep observing if something is off or not. Split the system into the subsystems. Remember, split without touching it, without interfering with it. You don't break the system. You'll have a tough time putting it back again. Recursively repeat until you observe the right system which is under duress. So what do we expect from this observability? When we say the system is observable, what are the key things that we usually track? In my experience, I split them into 4 buckets. The first bucket is behavior confirmation, what we also call as system monitoring. I should be able to look at a system and say, green, looks good. Red, here's a problem, except cameras. When they show red, they're working. No, that's an anomaly there. Performance attributes. When you look at a system, how good is this? Observability should be able to tell me the performance of a system. Fast, slow, good, bad. Cars, everybody, speedometer, it tells us. That's observability. Error detection. My expectation from a system is that if there is an anomaly in there, I should be able to land onto that without having to ask. Now, some people call it logic debugging as well, and there are various variations of it, or intrusive investigation. Without touching the system, I should be able to intrusively investigate every time I see something is going off. These are my expectations from a system when somebody says, hey, I am observable. We're going to split these down. There could be words which will make them easier to understand. Why is this not working? Well, of course, this slide has to exist in every talk. So I just kept it there, because I've had a talk, I gave this talk and people said, but you did not speak about the pillars of observability. Cool. So just for that, this is here. All right. But logs, metrics, traces, these are the data types that exist. The most common question that I get asked after this, I already have traces. Do I need metrics? You get asked this question. How many of you have encountered this question? At your org, outside? Nobody? Oh, you have. Great. All right. Others are just scared to raise the hand. Yeah. We emit logs. Are we observable? I'm not kidding. I've been asked these questions. You know what? Logs, metric, traces. The reason why you get asked this question, project managers have ruined this for us because we have this inane thing. Every time you see 3 things, they force you to choose 2. No, that's it. I've been conditioned now in my life. Every time somebody shows me 3 things, I'm like, oh, I got to choose 2. The next question is why? So, I can have all 3 if I want. Yeah. It's like they guilt me, picking 3 out of 3 is greed. It's expensive. It's extravagant. Just pick 2. No, I'm going to pick all 3. Again, expectations from observability, behavior confirmation, performance analysis, error detection, intrusive investigation. I want to do all 4, but not on day 0. So what is this maturity model? But before we get to that, a lot of people tell me observability is for engineers. Have you encountered a team leader, a product manager, or a CTO who says, all of these logs, metrics, traces, don't tell me, they are for engineers? Have you encountered this? Product managers will tell you, hey, I got my dashboards elsewhere. Kibana is for the developers. A customer success team will tell you, I got my dashboards elsewhere. This is for engineers. Let me break that for you. This is the most common thing I hear. These are for engineering teams. Our product and success teams have different dashboards. They act like as if they have their own data. Where does this data come from? To get to that, the simple question that I ask them, the need for observability is always felt when something goes wrong, not when everything is going right. So the question is, when something goes wrong in production system, what's the first thing that we do? If it was for engineers, is the first thing that a company does is that they start live debugging the code, because logs, traces, they are for code, right? Like what happens? What's that first step? This is that recipe that needs to be distilled. This is the life cycle of things going wrong, or at least what I've dealt. Like over a decade when I've held a pager, this is how I've gone about doing things. The very first thing when something goes wrong is I ask, how many customers are impacted? I remember there was this page that used to come up, and every 3 in the night, there used to be a pager that would wake me up and say, well, the logout system is down, disk is 95%. I don't know who filled that disk, but still, I used to attend to it. One of these nights, I asked myself this question: how many customers are trying to log out at 3 a.m.? And why can't they log out at 9 a.m.? Who is it impacting? And the answer was one customer. So I go back to sleep, man. I don't want to debug this. Important question to be asked. The very first thing that something goes wrong, should I even attend to this? It's a very logical thing. So identify the impact. Next, don't fix it. Notify the stakeholder. All of us SREs, we always have a boss. We tell them, hey, business impact, you handle it. I don't know. You tell me whether should I fix it or not. Post that, do not jump to fixing it. We have always learned from Windows, restart. The first thing that we do, always restart. Second thing that we do, roll back. The third thing that we do, allocate more resources. That's how Jeff Bezos make more money, right? These are the 3 things that we do. And we wait. Does it fix the problem? If it doesn't, then we communicate further. If it does, we say, okay, everybody go back to sleep. Problem has been fixed. And the last step is debugging. So the one that we fear that observability is about is actually down below in a corner. It's the 5th step. Nobody cares about that. Businesses are usually resolved in 1, 2, 3, and 4. I've been on live call. I'll give you an example. This was a live cricket match going on. Cricket is a game that is very popular in India. Like millions and millions of users watch it, more than the size of American population. No, seriously. I mean, that's how many people we have back there. So, and servers went down. Payment systems weren't working. What do? One SRE stood up and said, we will make this free. Ridiculous idea. Business loss. But come to think of it, the smartest idea ever. Because they realize, the match is not going to wait. We have customers who are waiting. We can charge them money later. And some of them will pay. Smartest decision ever. Well, some of them thought it is ridiculous. We're going to lose millions of dollars. What is more important? Lose millions of customers forever, or lose a couple of $1,000s right now? Great decision. Most problems you would realize can actually be solved before step number 5. How does observability help with all of that? Now go back to the question. When somebody asks you, which one should I use? Logs, metrics, and traces. The answer is all of them. The best question is, in what order? Where should I start my observability? Should I start logging today? Or how much should I be how many metrics should I have? What cardinality do I need? And the answer to that is not in a sequence. The answer is, what do you want to do with it? Do you want to identify the impact of it? And if you cannot answer that today, then go invest in that right toolchain for it. A log will not tell you. If I dump a 10 gigabyte log at you and say, okay, go figure out your system state from this, you cannot do that. Obviously, you need some metrics. Now you want to debug something. And if I give you metrics, you will say, I already know the system is bad. I want to know which line of code is broken. So you want the log lines. Each one of this will give you a separate aspect of observability. And you need to identify based on the journey that you are in. Now, went too fast. Yeah. To remember what you saw, you have to reap what you sow, which means the data that you will emit is the data that you will see eventually. To answer these questions, you need to have the right data underneath. What are these kind of questions? Now, Once I've agreed, let's get to this. Let's see the cycle of the data. How does this data get emitted? It is a very sequential step. To answer a question that you cannot today, you need to instrument that data. Instrumentation is your code has to start emitting that data. It could either be a log line. If it's a new metric like monthly active user, some line of code would have to be changed. If you don't care about monthly active user anymore and you care about daily active user, some other line of code has to be changed. This line of code that needs to be changed is called instrumentation. Sadly, you always have to go to the developers for this. Post the instrumentation, the next step is emission of that data. The third step is you store this data and you collect it somewhere. Fourth step is the query of this data. And last is you create those pretty dashboards. Now, here is I throw a large picture to you, but this is the most important one. If you now see the classification of observability problems, you would have seen a bunch of these words already around. You would see hotel, you would see Loki, you will see ClickHouse, you will see Elastic, pick any name. These are not the entire gamut of it. I've just taken a few samples here. The next time that you encounter these words, now you should be able to put them in a mental model. Is this supposed to solve my instrumentation phase? And if it solves my instrumentation phase, means it allows me to collect more data or more kind of data, depending on the pillar that I set on. Is it an emission stage phase? Is this product going to help me emit more data? Then I solved that. Is this product that I'm encountering going to allow me to save better data? So next time when you hear the word ClickHouse, where does it sit? It doesn't solve your emission problem. It doesn't solve your instrumentation problem. It allows you to store better. So if your problem today is about you're not able to store large amounts of data, but you have the data with you, then this is the layer in which you need to look at that product. Based on which stage of the problem that you are in, you would pick the right tool according to it. Now that you have the data underneath, now what kind of questions can you answer? And this is a recursive cycle. I want to cover a bunch of questions here. A various kind of question that if you're not asking, you should be asking, or I'm sure you would have asked at some point of time. Have the request latencies increased? Standard question, right? Like we keep getting asked this about a performance of a system that request latency. What kind of data would we need for it? Now go back into the journey and realize, are we capturing request latency anywhere? Is it being emitted? If it's not, start with instrumentation. Do we have the right storage which we can actually save this data at? If not, let's set up that. Let's set up a new metric system. Do we have the right dashboards where we can query this every time we need? Depending on what you don't have for the question, you may have to invest on the right stage. Now, how do these questions evolve? Once you're done answering this question, you would be more curious. You'll say, have request latencies increased for customers in EU region? Which means you may require an additional field in your data set. You may or may not have that field. If you don't have that field, you start at the instrumentation phase again. If you have that field, good, great, you can answer this question. Now there may be another segmentation required. Have request latencies increased for customers on Android? Which means you may not be emitting from mobile devices. Maybe you're only emitting it from the backend. So now you need to solve the emission problem. It could be another problem. Another kind of question that may show up. Have these request latencies increased since the last deploy that I did? Which means now you need to think of a large duration of a problem. You're not speaking about saving data for a day, for a two. You need to solve the storage problem now. Or it could be a big problem where you need to save a year worth of data. Now, if the answer to this question is not found by you, which means the problem is at the storage layer now, because you need to keep year worth of data. These are the questions that will allow you to observe more. They will force you to solve the exact phase of the problem during your journey of observability where you may be at. Now, these are just questions that I can just keep going on and on. Have these request latencies increased because of an auth service? Now, to answer this question, does anybody want to take a guess what kind of the right data pillar that we'll need for a question like this? This one, probably, auth service. Tracing. I have not seen a system by which I could answer this question by not enabling tracing. So each one of these will warrant a newer kind of effort to be done. So there's no observability which goes from I am done collecting all data. Let's buy the best database, install it, and we are done. As newer questions emerge, you may have to go back and solve these problems again. Ultimately, what does it mean? A system can only be translucent. A fully transparent system will become opaque due to its own bloat of telemetry. Now, why is this important? Because many a times we have this expectation that once we have put in an effort towards observability, I may not have to repeat this sprint cycle again. But that's not possible. Not every single line of your code base could become observable. There are going to be dark spots about it. You know, as somebody in the morning had said, every subsequent nine that you unlock is going to cost more and more. What is that cost? This is one of the costs. The other cost would be setting up large databases around it, behind it, or well, you're giving that money to Datadog, or you're giving that money to New Relic. Somebody you're paying because that is the amount of observation that you would have to keep somewhere and you'll have to query somewhere. These costs keep compounding. Nobody has infinite budget. If anybody has, please contact me. So, no, I mean, I'd like to take a pie, man. So, again, question being, the point being, you have to be comfortable with a certain amount of translucency. All systems will only remain to be as much observable, and you have to be okay with it. Based on where you are in the journey, asking the right questions of what does this unlock? What does it get me? What business revenue does it really get? You will decide at what stage do I have to be. You will move from anywhere being completely opaque to being completely observable, but you never swing the other way. If you're on the leftmost side, well, you're doing something wrong, or your business is just new, you're starting out. You know, like it's day zero of your business. If you're on the far end of the spectrum, on the complete right hand side, oh, you're blowing money. Yeah, your investors are going to come after you, and so will I. Somewhere in the middle, pick the sweet spot. Pick the sweet spot. You will see that the largest companies, the FANGs, they try to oscillate towards the right because at their scale, even a second worth of downtime can actually cost a lot, like the Google Ads example from the day. But for a young startup, it doesn't really matter. We can opt to be non-observable for certain parts because we have only so many people in the team. And the question, rather than asking the system, we can ask a developer. Hey, such is a behavior. Can you identify what could be going wrong? And you'll be surprised. Developers are so smart at this. The moment you tell them the right symptoms, they tell you the exact line of code which is broken, and then they fix it as well. You know, so swing, understand which way do you want to be. Now, coming back to this photo. Next time when you encounter a tool and you see a new one, you should be able to look at this and understand, hey, where am I in my observability journey? What level of translucency am I unlocking or am I getting rid of? What level of observability am I unlocking? Where am I in the exact stage? Do my questions get solved with the existing data types do I have? Like if I come to you and I say that, hey, I will give you the best tracing visualization layer. It will help you become reliable. You will say, I don't use microservices. Why do I need this? Although everybody uses microservices these days because the cool thing to be done, monoliths are long dead. I don't know why they don't build those applications that way, which are simpler, but yeah. But you'll be able to translate this question back. Where am I exactly in this map? And take a smarter decision at it. Once they are done, now once you got these pillars and you got these data type problems and everything, comes the layer on top of it, which are these sophisticated outcomes, which are, am I solving for security? Am I solving for developer productivity? Am I improving the reliability posture of my company? Or am I improving the culture? Now, think about it. What would happen if I start investing in an alert ops tool right away? You know, somebody comes and tells me, I got the best. I think I'm going to offend the previous guy. But yeah, I mean, great tool. With that caveat, I want to speak further. What if somebody comes to you and says that, hey, there's the best alert ops tool that you have ever seen. We got the best anomaly detection. We do seasonality detection. And you ask yourself, but I don't even have metrics. So it's not going to work. It will not help you unlock the outcome that you want to achieve. So you realize To achieve those outcomes, I first need to go through the notion of setting up my data. Once I have my data, I have the tool chain where I do the basic stuff of monitoring it, observing it. Only then I would reach the next posture level. This journey is extremely important. We get, and I've seen so many people take these wrong decisions because they would be hoping, and they're not wrong, they just don't have this mental model. They are hoping that by building the next correlation engine, or picking up a tool which promises you the best correlation between logs, metrics, and traces, even when you don't have them, right? It's not going to change your reliability posture or make you observable. So keep this in mind. If you follow this journey, this maturity model, it helps you become translucent to transparent in I would say, a less trial and error way. This has worked for me over the past decade and a half. Maybe it helps you as well. Again, winding up the key takeaways, hopefully this gives you a mental map of the observability maturity, the way you should progress and the way you should go. If you already know this, well, use this to tell this to your CTOs, your product managers, your team leads, or whoever is not listening to you. Yeah, and hopefully you do this better. That's me. Thank you.